Okay, I think we're going to start right now. Welcome again to this tech dive session for April. Okay, we're going to make a tech dive on the platform, and we're going to cover several topics today. I will try to make it, light, and we were going to see several functionalities and possibilities available in the platform, as also a real use case in a smart grids vertical showing a technical and non-technical losses detection for distributors in the energy sector. Okay, so I will start just sharing my screen. Remember before starting that you can always send your question to the Q&A section here in the webinar, and I will kindly try to answer every one of them at the end of the webinar. Also, you will receive a survey at the end of the sessions to know what were your impression of this webinar. Okay, so let's start. Let us start. I will just share my screen. Okay, and this way we are going to see what we are going to focus today. Okay, so this is the agenda for today. I will start as I used to do every month, just explaining why should you use HAI, what are the keys, the reason why it is normally a good thing to move your task from the cloud to the edge, what is the benefit it's offered to you. Okay, then in the second point, we are going to see these technical and non-technical losses in secondary substation use case. Seeing this real use case we have prepared here in the Barbara platform. And then when we have seen this real use case, we are going to show the platform. I'm going to give a brief overview of the platform. So I will show you how to provision new devices, how to deploy applications and model using our marketplace, how to deploy also custom application. We will make an example, a real example of how to deploy a custom application in the Barber platform. And then we will see some more functionalities like how to manage devices, how to do bash commands to manage a big group of devices all at once in a single click. And finally, we will see some functionality related to high availability offers in the Barbara platform. Okay, so let us start. Okay, let's go to the first point. Why HAI? Okay, and I will start just defining what HAI is. Okay, and basically it is written here. This is the new technology that allows you to remotely deploy, run, and manage applications and AI model directly on distributed on-premises devices instead of relying on the cloud. Okay, so we come from a situation where most of the applications and model were running on the cloud. Now the Edge AI technology allows you to move this task, to move these applications and model from the cloud to the edge. Okay, and the question here is, why should I do that? Okay, what are the reasons why my company should be interested to run all these workloads in the edge? So here I have a good overview of these reasons. Okay, so for example, we have some key factors here like cost, security, privacy, and UI friendly. Okay, I will include one more, which is latency, and I will start with that one. The latency is one of the key reasons why we should move the workload from the cloud to the edge. If you want to have low latency, okay, you want to have quick responses, okay, you cannot rely on the cloud. Okay, obviously the necessary time to send any request from the edge, from any data source located on-prem, located on the plant for your customer, to the cloud, process there all the command and going back to on-prem, it takes very a long time, more time than if you are going to use an edge device where everything is processed locally. So latency, you need to have low latencies, is one of the key reasons why you should move this application from the cloud to the edge. Not only that, obviously, we are speaking about sending something to the cloud, going back. Obviously, you want to be more resilient. You don't want to depend on the internet connection. Okay, it's also a good reason to avoid processing your data on the cloud and doing it on the edge. Then we have another key factor, which is cost. Okay, think about when you have to deal with big amount of data. For example, in any computer vision use case, if you have to send all the data from your video stream to the cloud to be processed there and then going back, the amount of data make the cost to be really, really high. So that is a good reason also to keep all your tasks down on the edge. So that way you will save a lot of money processing your data there. Then we have other two key factors here, the security and also the privacy. They are really similar somehow, they are linked. But I will start speaking about the security. Obviously, there is a lot of good security solution also for the cloud. Okay, I will not say that the cloud is not secure because that is not true. I know that you can deploy secure solutions also on the cloud, but there is a one important thing here. Most of the attacks, the cybersecurity attacks done in the last year, like the 70% of them are directed or are targeting the cloud. So only because of that, the edge is normally more secure because it's more protected by all the cybersecurity available in the company. Okay, and also the privacy. It is one of the most important key points. Some or most of our customers, they don't want to send their information to the cloud. They want to keep all the data on the premises and they want to process it there. That is one of the best reasons we have for deploying all the application to the edge and processing all the data there. Okay, and finally, the friendly or the UI or the user experience, let's say. Okay, normally cloud solutions are more related to the IT department, where the necessary skills for managing all these applications requires high IT skills. Okay, not normally available for industrial customers or customers that they don't used to have this kind of skill. So a platform like Barbara that is focused on the edge allow those people with OT skills, not IT skill, OT skill, to manage all this application, all this workload in a much easier way. Okay, so well, these are the key factors that normally make our customer to move the application and AI model from the cloud to the edge. Okay, so once we have said that, I would like to show you a diagram of how the Barbara platform is organized, how it works. Okay, it is very simple. It is very simple. We are an edge orchestration platform. What does it mean? We can manage edge devices, what we call edge nodes, okay? And we also can orchestrate all the applications that are running on these edge nodes, okay? Here we have this diagram where we can see this blue box, which is a Barbara edge node. We call it Barbara edge node, and it is basically an industrial PC or a virtual machine, okay? We will talk about that later, but we are a hardware agnostic tool. We can manage any kind of device that is based on Intel or ARM architecture, and also we can manage virtual machines. So that is also a possibility. You can create a virtual machine in any data center available in your company, and we can manage this virtual machine as a Barbara edge node also. Okay. When we're speaking about virtual machine, we're compatible with VMware, KVM, Hyper-V, so you have a lot of possibility to create virtual machine and manage them using Barbara. Okay, here we have the first product in Barbara, the Barbara Core. What is that? The Barbara Core is basically an operating system. Okay, not only an agent, but an operating system, a full operating system that includes also an agent. We call this agent Node Manager, okay? But it is included, embedded in the Barbara Core product, okay? Why do we do that? Okay, why don't we have only an agent that you can deploy or you can install in any OS? Because one of the key features of Barbara platform is cybersecurity. Okay, so that is why we create around and design and develop around OS. We are focused on cybersecurity, so we provide this OS that is completely hardened. When you install this OS in your equipment, you will have no open ports, or the communication will be outgoing and secure. You will have file encryption, you will have secure boot, TPM support. I don't know, a lot of different functionalities to protect and to harden your device. So once you have this Barbara core installed in your device, it is automatically compliant with the AIC 62443 specification for cybersecurity in industrial environment. Okay, that is very important because it saves you a lot of time. You don't have to worry about that. You don't have to install the OS and then protect everything and configure the firewall, and everything is done for you. Okay, so you will save a lot of time and you can be completely sure that your device will be cyber secure. Okay, once we have this OS, this Barbara core running in our device, it will communicate with the platform, and the platform is composed mainly by three parts. Okay, we have, in first place, we have the API. Obviously, we have an API, and about the API, we have two more products. Okay, we will speak about the API later because it is documented, and you can use this API to integrate any Barbara functionality with any existing pipeline you may have. So you are not forced to use the UI. You can integrate that, but we will speak about that later. Let's focus on the other two products. Barbara Panel. Which is Panel? What is Panel? Panel is the UI, okay? It's the interface you can use to control all your edge nodes available, okay? See where they are, see what are the telemetries, configure them, deploying application, configuring the application, all these kind of things can be done using Barbara Panel, okay? And then we have another thing. What is the marketplace? What is Barbara Marketplace? We call it marketplace, but we are not selling anything here. Okay, I prefer to call it the application hub because it contains over 150 different applications ready to be deployed in a single click in your devices. Okay, so that way, using Panel, you can select any of the application in the marketplace and you can deploy them in the edge node here. Okay, and check one thing. We have here this plane. This plane is separating what we call the orchestration plane from the solution plane. Okay, and it is very important because Barbara lives only on the orchestration plane. We do not live on the solution plane. Okay, what does it mean? It means that you can use Panel to deploy application on the solution plane. Okay, so in Panel, you will see information about the device, about the status of the device, or the application deployed, or the configuration, or the logs, but you will never see any data belonging to the user. Okay, so we don't save your data, we don't touch your data. Okay, we are completely separated to the solution plane. Your data, the user data, lives in the solution plane, and this data is managed by the application we deploy using Barbara, but we don't touch the data. Okay, we will see it in some minutes in the example we are going to see. Okay, and finally, before going to the next slide, I would like to finish this part just mentioning that the Barbara platform can be deployed in different ways. Okay, for example, we have a cloud version of the platform, okay, a SaaS version. We can offer it. This is a public version with you can use. It is deployed on the cloud, obviously, and you can use that instant to control all your organization. Okay, in case you're interested in having your private instance on the cloud, we can also provide that. Okay, we are compatible with most of the cloud providers, so we can deploy the platform in any of the cloud providers to provide our customers with a private instance in the cloud. But even more, some of our customers, the big one, they want to have their own instance deployed on-prem, not on the cloud, but on-prem. We can also do that. Okay, Barbara platform is based on Kubernetes, so we can provide the possibility to install all the platform on your premises, any available data center or whatever. So in that case, you will own your own solution running on your premises, and all the communication between the platform and the edge node will be internal to your company. Okay, so that way nothing will go outside your organization. Okay, so well, let's continue then. And here I have one more diagram to show in a different way how do the platform work. Okay, here we have the edge level, okay, where we have an edge node. This blue box is an edge node, again, an industrial PC or a virtual machine. Here we have the Barbara core. We can see how we can use panel and marketplace being accessed remotely by a browser, okay, to access the UI, and then we can use panel to control the Barbara core and deploy different kind of applications, an AI model there, and orchestrate them. Okay, so this way, all this application can be accessed locally from the same local area network. Okay, you can access all these solutions using the local area network, but also we can provide a remote access to this solution using a VPN that we also provide and that we will see later. Okay, so well, this is more or less a good overview of what can be done using Panel. Okay, and having said that, let's move then to the use case we are going to see today. Okay, this is the technical and non-technical losses detection in secondary substations. Okay, this is a use case for the energy and utilities vertical, where we normally have different kind of substation, primary substation, secondary substation. Primary substation are normally used to interface high voltage to medium voltage, okay, and then we have the secondary substation that normally interfaces medium voltage to low voltage, okay. So normally, well, this kind of solution can be deployed in any one of them, but we are focusing here. This use case is more is related to the secondary substation, those ones that change the voltage from medium to low voltage, okay. What is happening in those situations? Well, here I have a slide that shows the current challenges in this use cases, where normally the data from that substation. Think about, we have normally a lot of secondary substation deployed all over country, on the field or whatever, and normally this data is not available in real time. Okay, and that way it's often underutilized. Okay, so when we have insight from the data, normally it is delayed. So any issue that may arise with that data is normally identified after days or weeks later. Okay, so we don't have the chance to react to these anomalies on real time. Okay, also we don't have a mesh intelligence in the substation. Okay, we normally are all for to do only reactive operation instead of proactive management. Okay, so if we don't have real-time insight of what is happening in the substation, we cannot be proactive. We cannot be proactive maintaining our substation. Okay, we have to do all the action we do are reactive. Okay, and finally, since we have a really fragmented infrastructure with a lot of substation deployed all over the field, it makes it difficult to scale monitoring and control across the network. Okay, so that is something that is also happening right now. So what is the opportunity we see here, and how can we improve this situation using Edge AI? Okay, the proposal here is enabling real-time data processing at the substation level with modern edge computing. In plain words, putting an edge node in the substation. Okay, so that way we can read all the information of the substation on real time we can process it locally. We can have a database within, with all the data stored there, and we can apply AI model and different processes to extract value from that data. Okay, we can have visualization dashboard, etc. And we can also integrate this solution with any available system in the DSO. Okay, so that way, for example, a substation can trigger an alert to another service available in the DSO, indicating some event that is happening on real time on the substation. Okay, so that way in the DSO you can have a clear view of the situation of all your substation deployed on the field. Well, not all or just the one you select, okay? But it is what we are proposing. So this way we are transitioning from reactive to proactive grid operation, and we are also deploying a cyber-secure, remotely managed and standardized infrastructure across substation. Remember, we are compatible with AIC 62443, so you can be safe that way. Okay, so once we have said that, let's see what is the architecture we are going to deploy in our secondary substation. Okay, here we have the diagram. Okay, check. We can see here a secondary substation. Okay, just an example of secondary substation that normally have, well, a lot of different systems depending on the kind of substation, but it not usually have some transformer. Obviously, it has some more control equipment, like they are generating data in real time. So what we do is putting one of these devices, well, this is just an example, an industrial PC, in this case, a Barbara Edge node, okay? So we are installing one Barbara Edge node inside the secondary substation. In this example we are going to see today, we are reading a sensor, a smart sensor located on the substation. So we are going to have visibility on some data. Okay, we're going to see some data about the voltage, about the current, about the transformer situation. Okay, so that way we are going to read all this information using this piece here, a Modbus connector. Okay, these are the application I'm going to deploy in the Barbara Edge node. So every one of these pieces is doing a concrete task, okay, and all together create the architecture. So in first place, I have the Modbus connector. The Modbus connector is basically connecting to this smart sensor using Modbus protocol. It reads the information I configure, okay, and I am going to publish all this information in this local MQTT broker. What is that? An MQTT broker is basically a messaging service that allow me to communicate different application inside the edge node. So this way the Modbus connector is reading the information from this sensor and publishing here in the broker. In the same way, I have a database injector, which is a small application that is reading all the information available in the broker and publishing it in the local database. We are going to use Influx, by the way, at this is a very popular real-time series database, very convenient for this use case. So in this database, we're going to have all the information received from the sensor. And now we have one more piece here, an AI model, okay, that is reading all the information in the database. It is making some predictions about technical and non-technical losses in this substation. Okay, so this way it is making its magic, let's say, using AI, detecting or estimating the amount of technical and non-technical losses and saving this prediction again in the database. Okay, and finally, what we are going to use is Grafana. Grafana is a really popular application to create dashboards. So it will allow me to have a visualization dashboard with all the information and reading in real time from this sensor I have in this secondary substation. Okay. Again, since we have this broker here, we could connect this broker, this messaging service, to any central system on the DSO. So this way we can use this messaging service to alert, to send consolidated results, to send, I don't know, events, or to integrate the functionality we have in the edge to any processing service you have on the central system. So this way, from the central system, you will have visibility of what is happening in each substation in a central way. Okay, that is also an option. Here we don't have this integration, but it can be done easily depending on the application you have in the central system. Okay, so basically, this is what we have deployed, and what I will do now is move to Barbara panel and show you this use case running on real time. Okay, so let's go there. I will just change to panel. Okay, well, we have panel here, and I will enter in this account, and I have a group created for this. For this use case, because I have not one, I have a couple of edge nodes in a couple of substations. Okay, we can see where are they located in the map. Okay, in fact, they are located in Nigeria. Okay, so I can access this device remotely. I am in Spain, in Madrid right now, in the Barbara offices, and I can access these devices located in Nigeria remotely. So here, I have the same use cases, the same use case deployed in both substations. Okay, so let's go to one of them. Okay, for example, the GARQ1, and here we will see it later with detail what does all this information we have available here means. Okay, but I will need from this screen, I will need just one thing. In the network card that we will see later with more detail, I have this VPN. Okay, so this is the IP of my edge node in the VPN that is enabled via Barbara platform. Okay, so I can use this IP to access remotely to my edge node. Okay, but I will move to this part here, the workload, where I can see all the applications that are running in this use case. Remember, we were speaking about a Modbus connector, we were speaking about MQTT broker, an ingester, a database, an AI model, and a Grafana, and that is exactly what we have here. We have the Modbus connector, the broker, the ingester, the Grafana, the InfluxDB, and the AI model. This is exactly the same. Okay, so for example, in the Modbus connector, here is the Modbus connector. This is an application that has been deployed in the edge node using Barbara. So here, for example, I can see the configuration. And in the configuration, I can see that I am going to use Modbus RTU. This is the path where my smart sensor is connected, and I can, for example, declare the device name of my sensor, and then I can configure the mapping with all the variables I am going to read. Instant active power total, instant active power phase B, phase C, phase A. I have power factor average. Here is where I can declare what are the variables I need to read from this sensor using the Modbus protocol. That's all, okay? So that way I have this Modbus sensor running, and it is just publishing all the information in this broker on real time, okay? So the information is published here. In fact, I can do something. I can use it. I can use an application called MQTT Explorer, okay? And using the VPN, I can connect to this MQTT broker this way, and now I can see the messages that I am receiving from this sensor. Here you can see maybe a little bit small. I try to set it bigger, but anyway, here I have all the information that I am receiving from this sensor on real time, okay? So here you can see how the messages are reaching the MQTT broker. Once we have the information in the MQTT broker, it is moved to the InfluxDB database, and it is processed by this AI model. And finally, I will have a Grafana with this visualization dashboard. Let me show you how to access this Grafana, okay? I have here this URL. I just need to click here. And this way I can see the dashboard with all the information that reflects what is happening in this secondary substation that, remember, is located in Nigeria. Okay, so well, here we have all this information in real time. Okay, remember, I am seeing the information from last 24 hours. We can see, for example, I don't know, last 3 hours, something like that. Okay, and I can refresh it. Okay, so remember, we are seeing information on real time. Okay, so this way, what do we have here? We have like three different dashboards. The measurement or the DT analytic voltage and current and loading dashboard that reflect all the information I'm reading for the sensor. Here we have the voltage, okay? We have phase A, phase B, phase C, the transformer loading of this transformer. Then we have some voltage analytics, okay, with limit. Then we have the current and balance. We have the phase current analytic, the frequency of the network, okay? We have also the transformer loading on the historical values and the power factor of this transformer, okay? So here we have the information we are reading from this transformer. Is that all the information I can get? No, I could get even more information if we have more data sources in the substation. Depending on how many information you have, we can apply one AI model or another. We will have more accurate result or less accurate result. But we are, in this sense, this use case is really, really flexible. Just with a very small amount of data, we can have a good estimation of technical and non-technical losses. Okay, so once we have all this information in our local database in the edge, I can move to the second dashboard where I will see the technical losses scenario. Okay, that is the estimation of my AI model with the technical losses. Just for making an introduction about technical and non-technical losses, what are technical losses? Technical losses, in a few words, are those losses related to physical reason. I mean, those losses that are inherent to the transformer process. Okay, so for example, we have the technical losses due to the transformer itself. We have the losses due to the copper, the losses due to the iron. Okay, so we can see how are they moving. Okay, and also we can see an estimation of the cost of these technical losses in the best scenario, the average scenario, and the worst scenario. Okay, so we have these three scenarios with an estimation of the losses in this substation. Okay, so when we have this information from technical losses, we can also see the information about non-technical losses. Here we have this dashboard in parallel. So what do we have here? Non-technical losses are these losses that are not inherent to the physical reason. I mean, for example, fraud or incorrect configuration of the grid, or I don't know, different reasons. Okay, that losses due to different reasons than the technical ones. Okay, so here in this dashboard, I have an estimation in kilowatt hour of the non-technical losses in this secondary substation. I have also an estimation of the cost in money in the three scenarios I explained before. We have the best scenario, the average scenario, and the worst scenario. Okay, so we can see all these predictions. Okay, and then I have more information. For example, the phase with more non-technical losses. Okay, so depending on the moment, is B or A, so it is changing. Okay, so we have also the time of the day, or let's say the time range with peak non-technical losses. So now, for example, we can see we have this value from today. Okay, I have also values of, I will increase the I will increase the amount of time we are seeing because it is more interesting to 12 hours. Okay, so I can see also the current and percentile of current with several percentiles. Okay, and also a heat map of the non-technical losses in different times of the day. Okay, and finally we have another dashboard with all the information for the last 30 days. So I can see the phase that had more technical losses in the last 30 days, the time of the day where we are having more non-technical losses, and also a heat map of all this information. Okay, so well, again, this is the dashboard for our first secondary substation. I could go to Barbara panel. I could go back here. We have seen the Garkey secondary substation, but I could do the same with this one, with this another one. So I could also enter here, and just clicking here, I can see also the dashboard for this all other secondary substation. Let me enter, just providing my username as my password. And this way, I will have the similar dashboard. In fact, it's the same dashboard, but with different values. Okay, so we can see both substation on the same time. Okay, so well, this is the way we can control and we can add intelligence and we can apply AI model to our secondary substation to provide higher visibility of what is happening on the substation in real time. And it's open really a lot of possible use cases from technical, non-technical losses to predictive maintenance to, I don't know, a lot of, production estimation or consumption estimation, but there is a lot of different possibilities. When we have this Barbara now there, it is very, very easy to deploy different AI model to collect any kind of data available in the secondary substation and to integrate these values and this analysis to any system available in the central system of the DSO. Okay. So, well, I think with that I have covered um, everything I wanted to mention about this use case for smart grid and for DSOs. In case you have any question, please you can write it in the Q&A, the question and answer section. You will find it in the here in this interface. And anyway, we can check it later in case there is anyone, and we can provide that information. When we have covered this use case, I would like to continue giving you a brief overview of what is possible using Barbara, okay? Because as I mentioned before, Barbara is a really horizontal platform. We are not limited to this use case, obviously. We can deploy any imaginable use case for any imaginable vertical, okay? So we are not limited to smart grid, we are not limited to technical and not technical losses. So my goal today is just showing you this overview of the platform, and I will start in the first time. Well, I have here a slide, like I almost forgot it, where I mentioned some of the solution we can provide, just some basic example. But for example, using Barbara platform, we can deploy UNS. That is one of the most popular use cases in the last time. What we are doing is mainly deploying this kind of UNS architecture that help you to have a single source of truth with standardized data and using an unified namespacing, okay? So you can integrate any existing service in your organization to this single source of truth. So you forgot about this spaghetti integration nightmare that sometimes happens in industrial organization using this kind of architecture that make everything simpler and easier. Okay, we can also provide predictive analytics. Okay, we can help you to get value from the data. Okay, using AI models and using any kind of intelligence in the edge, we can analyze the data you have and get insight, real value insight from that data that help you to take better decision and optimizing your process. Okay, we can also deploy computer vision solution. We are not limited to industrial data. We can also integrate with cameras, and we can read video stream and analyze them in real time. having really a lot of different use cases when we're speaking about computer vision. We can also deploy software-defined automation tools. One of the most popular use cases in the last days is the virtual PLCs. Okay, so we are moving from a situation where everything was hardware, and now we can deploy virtualized equipment, okay, using only software. So that way we can deploy, for example, virtual PLCs on one of these Barbara Edge nodes, and we can control them remotely. Okay, that is one of the possibilities we offer using Barbara. And finally, we can also deploy cybersecurity solution that help you to control and analyze what is happening in your network. Okay, so using also AI, they detect threat, they detect abnormal behavior, strange pattern, and give you how to say, give you insight on how to improve your security in your internal network. Okay, all of these solutions are available in Barbara, and we can deploy them using different applications, all of them available in our marketplace. That said, let's go to the platform. Okay, and I would like to start speaking about devices. Okay, we mentioned it before. We are hardware agnostic. We are not limited to one hardware. We can run any industrial PC that is based on Intel or ARM. Let me show that in panel. Okay, I am going to move to panel again, and here I can see the list of compatible hardware right now with the Barbara panel. Okay, as you can see, we have a lot of different possibilities from very basic devices like, for example, a Raspberry Pi, okay, to the most complex industrial servers from the well-known vendors, most well-known vendors in the market. So you have a lot of different possibilities, including also devices like, for example, the NVIDIA Jetson Nano or Orion or AGX that allow you to run AI models, okay, on this kind of devices using the GPU, okay? And not only physical devices, we have also, and I mentioned that before, the virtual machine images, okay? So check, we have different Barbara OS per device. We don't have just a single generic OS, but we have a specific OS per device. Why do we do that? Mainly because of two reasons. The first one, we want our OS to be as light and secure as possible, so we remove everything that is not necessary in each specific device. Okay, so this way we are making it lighter, and we are also reducing the surface attack of our OS. But the second reason, and the most important one, we want the installation of this OS to be in just one click. No configuration is needed, no complex steps are needed. Any kind of person with or without knowledge can install this firmware in the Edge node. It is just clicking install, and that's all you need. At the end of the installation process, you will get an ID, and using that ID, you can go to nodes and you can add your node to register one or several new equipment at once in the platform. So the provisioning system or the provisioning process is really, really simple. Just one click, and that's all you need to do. Okay. When we have said that, we have been speaking about the web, we have been speaking about the cybersecurity. Let me show you how we are protecting the device. Okay, so these are the list of cybersecurity measurement we have available in the Barbara core. Okay, so for example, we don't have root access. You cannot access the device using SSH, using any other kind of protocol, not even Docker, using root access. Okay, but we don't have also any user password access. Okay, so we cannot or we eliminate the access using traditional authentication method. It is not also possible to do. You cannot get into our machines, okay, using this kind of methods. All the ports are closed, okay? So we restrict the network traffic only to authorized communications, okay? This is very important because when you are deploying an edge node on-prem, on a plant, on a factory, or whatever, normally you have to follow the cybersecurity restriction that the IT department normally have. Okay, and doing it, we only need to use some ports, very few ports, and always in the outgoing way. Okay, so that make everything easier when we have to deal with the IT requirement to convince them to use Barbara node because we are hardened, as we mentioned before, and we are safe to use. Okay, so for example, we don't have incoming communication channel. Okay, so unless we explicitly declare this outgoing communication or incoming communication channel in the solution plane, okay, always, not in the control plane, but by default, everything is closed, okay, and we don't allow any incoming communication channel, okay. Then we have secure outgoing channel. All the outgoing channel we have in the control plane are obviously secure using certificates per device, different certificates per device, so on and so forth. Okay. Then we have the file system isolation. Okay, so files and processes are segregated to prevent data breaches. Okay. We have full data encryption. All the data included in the Barbara node is encrypted using this standard algorithm. Okay, we have a matched identity management. So each node use unique cryptographic certificate. So it provides a robust authentication and authorization mechanism within the communication system. Okay, we don't have a generic cryptographic certificate, but each node has its own one. Okay, we have a secure boot, as I mentioned before. We have trusted provisioning. We have TPM support, and finally, and very important, we use secure and signed auto update. That means that you can update your firmware remotely. We will see how in some seconds using Barbara panel in a very easy way. So that way you will keep everything updated in your platform. Okay. Once we have said that, okay, let's move to this part. How to deploy applications and model in a Barbara edge node. Okay, so let's go to panel. I would like to show you how easy it is to do that. Okay, in that case, I will just clear this group. I will show all the edge nodes available in this organization. I am going to enter in this one. This is an Advantech APC 301. Okay, I have available here, and I can go to this section, the workload section. Here is where I can deploy things. Okay, what kind of things can I deploy? I can deploy three kinds of things. The first one, and I will start by this one, marketplace application. Okay, let's go to marketplace. I will show you our marketplace. We have a link here, and this is where you will find really a lot of applications that help you to do all the necessary tasks to create any architecture or to manage any kind of data flow in the edge node. Okay, so here we have the full list of applications, and everything is organized in categories. Let's start from the industrial category. Okay, what do we have in the industrial category? Here we have basically these connectors, this industrial connector. We use one in the use case I mentioned before, the Modbus connector. Do you remember we were using a Modbus connector to read information from the smart sensor and to set that information to the MQTT broker. Okay, so in fact we have here this Modbus connector. This is here in this part. Okay, so here in the industrial category we have all these kind of connector application that mainly read information from external data sources. They connect to any external data source and read information using different protocols. We have Modbus, we have OPC-UA, OPC-DA, Profinet, BACnet, CBNF7, I don't know, a lot of different possibilities to read information from any existing data source in the industrial world. So that way we can read data, okay, and move that data from the data source to the edge node. When we have it in the edge node, normally we publish it in an encrypted broker or whatever, okay? But we can also do some more things. We can also send this information or part of this information to any third-party system, also very popular in the industrial world. So, for example, you are seeing here Aviva Edge Data Store. This is a connector to send the information available in the Edge node to the Aviva Edge Data Store, okay, to the Aviva solution. But we have also the possibility to use, for example, well, HiveMQ, we have it TDR also, but it is maybe more messaging service. But we have Ignition, for example. We can deploy an Ignition instance in the edge node, or we can integrate the data we are reading to any existing Ignition gateway. We have Litmus, we have Neuron, we have a lot of different third-party solutions. So we can integrate your data with any of these third-party solutions located on your architecture. But even more, we can also send information to the cloud from the edge. And that is why we have this kind of application like AWS, like Azure IoT Hub, like Google Apps App, it's around here. Okay, so we have also this kind of connector that can get any information available in the edge node and send it to the cloud to be visualized there or processed there or consolidated there or whatever. Okay, so in this industrial category, we have information to read data, to integrate what data with any third-party system, or to send data to the cloud. Okay, then we have another category, storage. Obviously, when we are reading data, we need to store it locally because it is normally what we do. Okay, we store the data locally, so that way we can visualize it, we can process it locally. So it is very convenient to have a good database, and we provide really a lot of possibilities. Most of the ones available in the market and in our marketplace. So I don't know, Elasticsearch, InfluxDB, Mongo, SQL, MariaDB, I don't know. You have plenty of options, so you can deploy these databases in the edge node using the marketplace to store your data. You can choose the most convenient database for you, and that way you can deploy it to the edge node. Once you have the information stored in the edge node, you normally need to process this information somehow. And that's what we offer in the business intelligence tool. So here you will find application to read data and process it, applying, I don't know, software, AI, or visualize the data. You have plenty of options like Doris, Flink, Apache NiFi, Grafana, Flowfuse, I don't know, a lot of different possibilities. Node-RED is also very popular. I will deploy Node-RED in some second to see how can we do that. Okay, and well, a lot of different possibilities to process your data in the edge when you have it stored. Then we have, for example, also an artificial intelligence solution or category that contains AI models and AI tools to work with AI model locally in the edge. So, for example, we can deploy, we have this Edge Impulse model loader. In case you have any AI model and you have been using Edge Impulse, you can deploy this model to any Barbara Edge node and run it there. But you have also Jupyter, you have also Langflow, Flowwise, we have LLM tool like Oyama, we have computer vision solution from Ultralytic to process the information, the video stream. We have application to work with video stream. Well, we have a lot of different possibilities to work with AI, okay? And finally, we can also deploy complete virtual machines in the edge node, not only applications but also virtual machines. Okay, so this way we can deploy from a Windows XP to an Ubuntu server. Any kind of virtual machine can be deployed easily in the edge node. Okay, so this is one of the other category. We have communication solution, as I mentioned before. We have IT tools that help you to deal with the IT use case in the edge node. We have a complete smart grid category that contains AI model and connector like the AIC104 or AIC61850 connector to read the smart grid data. Okay, we have a lot of different possibilities here. Okay, so this is a good overview of what can be done using the applications available in Marketplace. Okay, let me show you how to deploy something really simple. For example, let's deploy a Node-RED. Okay, we have this Node-RED application here. So we can use it basically to, well, process data. Okay, this is a programming language. It's a visual programming language based on blocks. We can connect blocks. Each of the blocks make something. Okay, so well, I will go into the application itself, but I will show you how easy it is to deploy a Node-RED in a Barbara Edge node. Okay, so what I will do is deploying it. And here in the technical note of every application, we have all the information, all the necessary information to configure it properly, okay? So what you have here, the possibility to configure the user, the password, additional packages, and we provide default values, we provide template to do that. But the good thing about the application in the Barbara Marketplace is that really easy to deploy. We just need to click deploy. We just need to select Node-RED here, okay? And this way I can select the version. We have several versions published. I will select the latest one, but check it. We have this wizard. This wizard helps you to configure everything that was mentioned in the technical note, okay? So you can change the user, the password, you can set additional package, you can change the slot level, you can select the port where the application will be running, you can select the volume where the data of the application will be saved inside the Edge node. Okay, so this way you can configure the application, and once you are happy with your configuration, you can send it. I am just sending this application to this Edge node. Okay, and now check, we have a new card here. Okay, remember we have different cards in the smart grid use case we mentioned before. Now we have a new card here. You have seen how to deploy something. Okay, we have deployed just a Node-RED application. We can see in this card the name of the application we have deployed. We can see the version. We can see the status. We can stop the service and start it. We can update the version. We have, if, in case we have a newer version and we want to apply the new version, we can do it this way. We can configure anything again. Imagine I made a mistake in the user, in the password, whatever. I can change it here. I can send the changes and it will be updated on real time. Okay, and then I have also here a view of the logs of this application on real time. Okay, so we can see it has been deployed and now it is running. So now I can access to this Node-RED application also in real time. Do you remember how I accessed before to Grafana? It is the same. I just need to use the VPN. I will click here, and this way I will be accessing to this Node-RED I have just deployed in this Edge node. Okay, so this is the Edge node. This is the Node-RED I have just deployed in that machine, so I can start working with that and, I don't know, creating any kind of data flow to process my information the way I want. Okay, so this is one example. Let me show you another example. In this case, I will deploy something that is normally much more complicated to deploy. Okay, I will deploy a full ignition instance. Okay, again, I have here the ignition application. I have all the technical notes on how to configure everything, okay, available. And check one of the things we can, we will see it in the wizard, but one of the things we can configure is the ignition license key and the ignition activation token. So if you have a license of ignition, you just need to put it here and it will use your existing license with inductive automation, okay? So you don't have to pay anything to Barbara. We just allow you to bring your own license and use it here. That's all that you need to do. Okay, so let me show you how can we deploy an ignition in the same way. I will just click deploy, select ignition, and now we have the wizard to configure the parameters needed for ignition. For example, the user, the password, the edition, because I can select between a standard Edge, or Maker, depending on what I need. I will deploy a standard edition. In case I have my license key or my activation token, I can put it here. Then I can also select the port where all the services will be available. And finally, I can deploy that. I will have a second card in parallel where I will see that now I have an ignition that is just starting, okay? In some second it will be available. And I have the same. I have the possibility to change any configuration. I have the possibility to see the log of ignition in real time, okay? And now I will see that in some second it will be, well, it seems to be started. And now I can, well, it will take some second to show here the URL. Let me refresh this card, but it normally takes a little bit longer. Here we have it. So now I can use this VPN. So clicking here, I will be accessing to this ignition instance. Here we have it. Okay, and now I can log in using the username and password I configured in the wizard, and I can start working with that ignition instance. This is the way what Barbara works. Deploying application, interconnecting them, creating data flows. Normally we have a connector, then we have a broker, then we have a database, then we have something processing the data, then we have something visualizing the results, and we have some integration with third-party systems. That is a good general pattern for this kind of architecture, depending if you're using data collection or predictive analytic or whatever. Okay, so well, I will continue. Okay, because we have seen everything that is available in the marketplace, okay, which is quite a lot of things. But now let me show you that we are not limited to the application in the Barbara marketplace. Obviously, okay, you can deploy your custom application. You can deploy your custom AI model in a really easy way using Barbara also. Okay, so let me show you how to do that. Okay, I have this slide here to show how to deploy custom application. I will show you how to deploy a custom application. Okay, but I will start showing you how can we do that here in panel. Checking panel, we have this applications library where we can see. Here we have it. We can see all the application we have from Marketplace, and not only that, we can see also applications available for this kind of custom application, what I mentioned, okay? So we can add our custom application in this library, okay? I just need to select add a new application, and I have to choose if I want to deploy or upload, better said, a custom application based on Docker, okay? That's the requirement we have. You need to deploy application based on Docker images. So what you are deploying, what you are uploading to panel is a Docker compose file, what we call the manifest of the application. I will show you how to do that in just a minute, okay? But you can also upload your own AI model. Imagine I've been working with my data, I've been training my custom AI model, and I've been working, for example, with PyTorch. Okay, so in that case, I just need to select, I want to add a new AI model. Okay, I just need to choose that I've been using PyTorch, and then I can select the engine I want to use for serving this AI model. Imagine I want to use MLflow in this case. So now I just need to upload here a zip file containing the trained model in TorchScript format in this case, because I've been using PyTorch. If you are using TensorFlow, you are using same model. If you are using ONNX, you will use ONNX format. So depending on the framework you have selected here, you will need one format or the other. Okay, so you upload the AI model, and you can deploy it in the same way you do with the marketplace applications. Okay, so let me show you how to deploy, and we are going to deploy a very basic custom application. Okay, so I have prepared a very basic use case just to deploy a Grafana, okay? If I want to deploy a Grafana, I can go to Docker Hub and I can see that there is a Grafana, an official Grafana Docker image, okay? So you can use this image to run a Grafana service, okay, using Docker, okay? So what we use is the Docker Compose file, okay? I have created a Docker Compose file so we can run it locally in my laptop in the first place, and then show you how to do the same, but in a Barbara node. You will see how easy it is, okay? So I will do that. I can open this is VS Code, okay? And here I have the Docker Compose that is mainly creating this Grafana, okay? The Docker Compose file is declaring services. So we have named the first service Grafana. We are saying here that I want to use the Grafana official image. Here is where I am indicating that I want to expose the port 3000, so I can use this port to access my Grafana, okay? Then I have included an environment file. We can see it here. The environment file is mainly configuring the behavior of the Grafana image. So I can see in the documentation of the Grafana Docker image that we can use these variables to configure the username and the password that we will use to access the Grafana service. Okay, so the only thing I need to do is put in this variable in this file, and then here I am indicating that I want to use this file as the environment file. Okay, finally I am indicating that I want to save everything that is saved in this folder inside the container. I will save in this volume, Grafana data volume, okay? And finally, I declare a network called Barbara Services. That is the network used in normally in the Barbara node. But anyway, let me show you. I will just open a new terminal, and this way I will run this Docker Compose file. So I just need to do Docker Compose Docker Compose -f. I will use this file, okay. Docker Compose local, because I want to use this one, app -build to build this image. So if I do that, I will just running this service in my laptop. Okay, so what I'm doing here is running the service in my laptop. As you can see, we have a lot of different logs from the service. And if I open my Docker desktop, I will see that now I have a new container here called TechDive Custom Application, okay, that has been started 19 seconds ago, that is using the image Grafana and is using a volume called Grafana data. That is what I explicitly declare in the Docker Compose file. And now, since it is running, I can open my browser, and now I can put here localhost 3000, and I will be accessing to this image of Grafana that is running locally. What I do is basically running a service using Docker Compose file. Okay, so now I can set user, password, that is basically what I have declared in this variable here. And this way I will access this image that again is running locally in my computer. So what I want to do now is doing the same, but in a Barbara node. So what I will do is I will go to my edge node. Okay, in my edge node, I have to, I will select this edge node, for example, and check we have here this global secret. Here is where we can declare this variable that we have in this file. Okay, so the first thing I will do is upload this variable to this global secret card that is used from our custom application. I just need to upload from file, and I will select the file I have in this folder, okay, which is this one, Grafana, and I will use this file to upload the value to secret found. I add them. So now I will see that I have the GF security admin password with the value of password and GF security admin user with the value of user. Okay, so now I have the global secret available. Okay, if I go back to the Docker Compose, check that now I have another Docker Compose, which is basically the same one. Let me open in parallel. Okay. So I have the local here. Check the difference. The only difference we have is that now we are not declaring the same file. Why not? Because Barbara is automatically using the variable we have just uploaded to the global secret. So we don't have to put anything in this Docker Compose file. It is the only difference. I am using this one for local deployment. I am using this one for um, barbarational deployment. So what will I do? I will just open this folder. I will take this Docker Compose file and I will compress it. Okay, so I will just create this Docker compose.zip. I will go back to my Edge node, and now, well, I have to do something first. I have to create the application. So I will add a new application, Docker. I will choose this zip file containing the Docker compose. Okay, and I will name it tech dive Grafana, for example. Okay, so I will call it version 1.0.0. I can declare the platform compatibility mainly depending on the image of Grafana. It is compatible with all these architectures, so I will leave as a default, and I will add the application. So the application has been successfully created. If now I search for tech, I can see we have new application here with this new version added by myself. So now I can go back to the Edge node I was using before, the one that had the secret, okay? And now I will deploy this application. Okay, so I will select the application, I will select the only version we have, and I will send it. Let's see that now I have a different kind of card. It's simpler than the marketplace application card, okay, but it is the same functionality, and we have the status, the possibility to stop and start the service, the possibility to configure everything, and the logs again on real time. So now, if I use the VPN IP of this device, let me show you. Here we have the IP of this device, so I will copy it. And now I will open a new tab, and the IP of the device and the port 3000, I will be accessing to this Grafana version that I made using a custom application. Okay, so now I can use the same user password. Okay, user password to log in. This way, I'm just joining or entering in the Grafana application, and check a couple of things more. I have also a card here called volume, where I can see that we have this Grafana data volume. Do you remember that we have declared this Grafana data volume here? Okay, and we are using that volume to store the information available here. So in panel, I have information about this Grafana data volume. Now it has 0 byte because we have done anything with that, but it will always show the real size of the volume, and I can see all the information about that volume. I can see the path that I am mounting and the service that is using that volume, etc. Okay, so this way I can deploy custom application in an easy way. So I will just go on because I want to show you more functionality of the platform, okay? Very quickly. One, we have seen how to deploy custom application, how to deploy a custom AI model. Let me show you some of the functionality we provide to manage the Edge node. We have been seeing some of them, okay? I will go back to my previous device, okay? Check, when we enter in a device, we have two different tabs, the node information tab and the workloads tab. In the workload tab, we have the information about the application that we have been deploying, okay, and the configuration, all that kind of thing. Here we have the information about the hardware itself. So in the general information card, we have information about the hardware, we have information about the location, okay, and we can change it if necessary. We have information about the timing. We have also information about the telemetry of this device on real time with the, information for every core in the CPU. We have information of the disk of all the partitions available in the disk. All this information is here on real time. We have information about the volumes, as you can see. We have information about global secret, the same we did before. We have information about Docker credential. Imagine we want to deploy an application that is using an image that is hosted in a private repository. In that case, the edge node obviously needs a credential to access this repository. That is why we can add credential here, just indicating the URL, the user and password, and this way we can add private repositories. We have an analytic card that helps you to create graphics with any parameter you may need. Okay, so we have here all the parameters available. So, for example, I don't know, I want to see the disk usage in the last day for all the processes. Okay, so this way I can do that, and I will have the information of the evolution of the disk size. So I can create different visualization here, and I have this network card that is really, really important because it allows me to control all the information about the network communication of this device. Okay, so I can see all the interfaces available in this device. For example, here I have 4 Ethernet interfaces and 1 mobile interface. So I can enter here and see information about the modem. I can see all the parameters available in any Ethernet interface. I can set IP, DNS, default gateway, add IP alias. I can create virtual LANs even, okay? I can do a lot of things here in the advanced area. I have the possibility to enable or disable the VPN we have been using for access the device remotely, but also we can use proxy communication. We can declare and configure the IP tables in the device to make fine adjustment of the network traffic. So it is a really, really powerful car with a lot of functionality. But even more, we can also update the firmware of the device remotely, not only the OS, but also the node manager, this agent that is communicating with the platform. So we used to provide different updates for both of them, so you can apply the update whenever you think it is a good time for doing that. But also you can even reinstall. Okay, imagine you have any kind of problem and you want to reinstall the firmware. You can also do that using Barbara. Okay, and obviously you can manage the life cycle. You can reboot it, you can activate it, deactivate it. You can do a lot of different action on the edge node. Okay, so this is more or less the functionality we offer to manage the edge node as it. Let's continue because I would like to see a couple of more things in these 10 minutes. Okay, the first one, batch command, and the second and last one, the high availability. Okay, so I will explain both at once to save time. Okay, and well, they are in fact somehow related. We have been explaining how to manage an edge node, how to deploy application in an edge node using only one, okay, just because of simplicity. But obviously, the powerful feature about Barbara is that you can manage big group of devices on parallel. So imagine in the use case we have, where we have to imagine we have to update the AI model we are using for detecting losses, technical and non-technical losses in 100 substations. Okay, if we have to go one by one, it's a real pain. We cannot do that. Okay, so that is why we use batch command. What can we do? I can create a group with all my secondary substation, and then I can select all the edge nodes at once, and I can control them in a single click. That is batch. That is batch commands. Okay, we can do anything with them at once, from activating, rebooting, cleaning, changing any configuration, deploying any custom application or configuring them, deploying any marketplace application or configuring them, adding credential or updating the firmware. We can do anything. We just need to select the target nodes. When we have the target node, we select the command we want to use. And when we have the command, we have here an overview of what we are going to do. Okay, and check we are going to, in this case, we are supposed to be updating the firmware to 19 edge nodes in parallel in a single click. Very important. We have a couple of edge nodes here that are offline. That means that we don't have real-time communication with them right now. It's a really normal situation where we are dealing with Edge node. It is not a problem. Okay, Barbara can handle that situation. We can send the command to all of them, and as soon as they connect to the platform again, they will receive the command and they will apply it. So you will have all your devices in the same situation using the same configuration as expected. Okay, so this is really, really powerful for controlling big group of devices one and saving a lot of time. Okay. Finally, I will speak a little bit about high availability. Okay. And in order to do that, we have this cluster functionality in which I have created a cluster that is mainly doing the same use case with that I started this tech section with, okay, the technical and non-technical losses, okay? What is a cluster? A cluster is just a group of edge nodes that are working together, okay? Why do we do that? Because sometimes the customer demand us to run their services without any kind of interruption, okay? They want high availability for their services. If we need to um, assure that our services will keep running without downtime, we cannot rely on a single edge node. Because obviously, if we have any hardware problem or any power supply problem or any problem, I don't know, something happened with this edge node, the service will obviously be interrupted. Okay, that is why we can create cluster composed by 2, 3, 4, 5, I don't know, as many edge nodes as you need. A good number is three normally, okay? So this way you have redundancy. You have three nodes that are working together. Okay, in fact, here I have a cluster. Well, this is just an example. We are using only two, that the good number again is three. Okay, I have a secondary substation cluster composed by two nodes, two machines as parallel running the same use case. The good thing is cluster, well, there's a lot of good things when using clusters, but they have like two functionalities that are really, really useful. The first one, the virtual IP. Check here. I can use a virtual IP to access the cluster, no matter where is my application running, is in node A or node B, or if node A is down or up, or B is down or up. It doesn't matter to me. I have always the same entry point, this virtual IP. The second point, the second very interesting point is the volume. Remember we were using volume to share, to store the data in the edge node. Now I have another volume, but at the cluster level, okay? And the good thing about this volume we are seeing here is that they are shared among all the edge nodes in the cluster. So any information stored in the cluster volume is available to all the edge nodes in the cluster, okay? So this way, I can deploy the same use case we were seeing before, okay, with the Grafana, with the Modbus, with the Influx, the MQTT broker, the same, okay, and it is running on the cluster. If the edge node A is down because there were some hardware problem or whatever, the application, all the application and the edge node and the data, sorry, will be available to the other available edge node. So that way the service will keep running without any kind of interruption and you will have no downtimes in your service. Okay. The way of deploying application in the cluster is exactly the same to the way of deploying application in the edge node. I just need to press deploy. Okay, imagine we are going to deploy a Node-RED. So we have the same wizard I showed before with the user, the password, the ports we mentioned before, but now we have an additional step, this one, in which I have to indicate how many replicas of my application do I want to use. Okay, so you can select a single replica, only one instance of the application, or you can select two or three or as many as you want, okay? Or even using the global mode where you basically will be deploying one replica per device. So this is what you will normally configure here, okay? So this is the way of deploying services using clustering that, believe me, create a cluster um, And a good example for that is using, for example, ignition with redundancy. Okay, deploying an ignition instance with redundancy without Barbara can be a real pain. And using Barbara, you can do that in less than 1 minute. Okay, using the clustering functionality. So as you can see, it is very, very easy. I think with that, I finished all the things I wanted to cover today. I will just finish this technical dive session with a couple of things I want to show to you. The first one is the academy. Okay, we have an academy. This is in academy.barbara.tech. Okay, that is available publicly, and you can enter it and see all the information. Okay, so here you will see all the information about the platform. You will have information about some tutorial to deploy a data monitoring solution, a computer vision solution. You have information for developers in case you want to deploy your custom application. You have also all the information about the supported hardware, the documentation of the API in case you are interested in integrating any existing pipeline with the Barbara panel functionality, and well, everything is here. Okay, and one more thing, check we have a quick start defined to start working with the platform. This quick start is completely linked to the onboarding. Okay, let me show you that onboarding URL, onboarding.barbara.tech. Using this URL, you can apply here to have your own trial license of Barbara. Okay, we provide you a trial license. So this way you can start working with Barbara using an edge node we provide to you. So you don't have to worry about using an Advantech or another equipment. We provide you a virtual edge node so you can start using it as in a sandbox to deploy different use cases. Okay, and you can follow this quick start that will help you to start working with the Barbara platform very easily. Okay. So I will send to you all this information in the wrap-up mail. Okay. And that's all from my side. We are on time, just 2 minutes. I see no question in the Q&A section. So I think that is all for today. And well, you will receive a survey, okay? That I would like you to answer. It's just 2 or 3 questions, less than 1 minute to answer the survey, and it will give us some insight to keep improving this kind of tech dive session month by month. Okay, so thank you very much, all of you, for attending, and see you in the next tech dive session for Barbara. Bye bye. Thank you.